Hi all, welcome to lesson 9 unit 3. Our topic today is average rate of change. So I want you to pause the video and try the do now on your own. So the do now says state the slope for the linear equation table and set a set of points below. So you're given 3 questions and you want to find the slope. Remember your slope, if you have a line, your equation of a line is y equals mx plus b. Your m is your slope, the rise over run. B is your y-intercept, the point where the graph crosses the y-axis, right? So here, since the equation is given to you, if I rewrite it underneath, y equals mx plus b, what's in place of m? I have -3, so my slope is -3. Here, how do I find the slope? Going back to your slope formula, rise over run, right? Change in y over change in x. So my slope formula is m is the letter for slope we use. It is y2 minus, y2 minus y1 over x2 minus x1. So I can take any of the 2 points. I'm going to take the first 2 points. It won't matter. You would have taken the second and the third point. You will get the same slope for a line. Okay, so I'm going to do 5 minus 2 over -1 minus 0. Make sure you go in order. If you did 5 minus 2, you must do -1 minus 0. If you did it the other way around, 2 minus 5, then you would have done 0 minus -1, which would yield you the same answer. So it's 3 over -1, which is -3. So m is equal to -3. Okay, so now instead of putting in a table, I write it as root for C as an ordered pair. I'm going to rewrite the formula. M is equal to y2 minus y1 over x2 minus x1. So what is it? So if I say this is my x1, then this has to be my y1. If I said this is my x2, then this will be the corresponding y value will be my y2. So it doesn't matter what point you pick, okay? So as long as you're consistent, that is good. So let's make this. This is x1, y1, x2, y2. It wouldn't have mattered. And you can try it both ways. So I'm going to do 15 minus 7 over 4 minus 2. 15 minus 7 is 8. 4 over 2 is 2. 8 divided by 2 is 4. So your slope is 4. Okay, so this is how we find the slope for linear equations. So now you're already familiar with the concept of average rate of change. When working with straight lines, linear functions, you saw the average rate of change to be, what was it? Change in y over change in x. We also choose to write it like this. That's delta y over delta x, which is basically rise over run. Or you can write down the formula. This actually, let me rewrite this as, I don't want you to get confused at what does that mean? Change in y over change in x. The average rate of change of linear functions is y2 minus y1 over x2 minus x1, right? Or it's the same thing as writing as, doesn't matter, y1 minus y2, as long as you're consistent. If I did y1 minus y2, I should have x1 minus x2. It's the same thing, okay? When working with non-linear functions, non-linear means that they're not lines. The average rate of change is not constant. What does that mean? That's not going to be the same throughout. The process, however, is exactly the same. So now, instead of saying that we found the slope of a whole function, we're going to find the slopes of certain points from point A to point B. So what does that mean? Let's read this. For the function y equals f of x between x equals a and x equals b, average rate of change, the another word of average rate of change is same thing as slope. And if you start going to calculus, you'll be calling this the first derivative. So these are all the same words. It's change in y over change in x, which is f of b. Isn't f of b another thing writing as y, right? That's y2 minus y1 over x2 minus x1. Same idea. When the average rate of change is positive, the graph has increased on that interval. When the average rate of change is negative, the graph has decreased. You read your graphs, decreased, I spell it wrong, no, decreased on that interval. You read your graphs from left to right, and if it's going up, let's say, if it's going up, it's a positive, it's going down, the slope is negative, right? Or it has decreased over that interval. So let's go on to the first question. It says function f of x is shown in the table on the right. Find the average rate of change over the interval this. So whenever you're not dealing with linear functions, it's going to give you a domain or the x value for which you need to find the average rate of change, right? Average rate of change again is your slope. I'm going to keep saying it. So 1 to 3. So this is my 1. I'm just going to highlight that. And this is my 3. So I'm going to find the slope between these 2 points. So all I'm going to do is, m is equal to, so I'm going to do y2 minus y1, which is 16 minus 4 over 3 minus 1. That's all you're doing. I'm not going to call it m. I might call it average rate of change, because it's the question says average rate of change, so I'm going to abbreviate it. So 16 minus 4 is what? 12 over 2, which is 6. So that's your slope for those 2 points. The next one, how do you graphically determine the average rate of change? Function g of x is shown in the graph at the right. Find the average rate of change over that interval. So again, focus on your interval from 1 to 4. So when x is 1, what's my y value? You need to find that, right? It is what? 1. When x is 4, what's my corresponding y value? It's 2. So those are your 2 points. So you want to find the slope of those 2 points. It's the same idea, right? So your average rate of change is 2 minus 1 over 4 minus 1. So which would be 1 over 3. So my slope is 1/3. Example 3. So it says a ball thrown in the air has a height of this. So that's my function. So now this will be a little different, okay? I'm not given any points. Feet after t seconds. Again, this is a quadratic because t is to the second power, right? What are the units of measurement for the average rate of change of h? So this is asking me for the units. If I was to graph it, think about it. It's time. It's a function of t, so its time is going to be on my x-axis and my height is going to be on my y-axis, right? That's what it is. So now, how do you determine your units? Basically, it's again change in y. What's your height over time? That kind of gives your idea. What do you measure height in? What are we measuring height in here? In here, we're measuring it in feet, and time is being measured in seconds. So your unit will be what? Feet per second. So that's how you determine it. That's like the easiest way you can determine that, right? Find the average rate of change. So now it's asking me to find the average rate of change of h between these 2 t values, 0 and 2. But I don't have any points. How can I find that? So what we're going to do is we're going to use that equation. We're going to find h of 2 and we're going to find h of 0. Do you agree? Your 2 and your 0 are your input values or your x values. If you substitute them into the equation, you'll end up with your what? Y value. And that would give you your y1 and y2. Okay, so let's do that. You can all put that in the calculator also and literally go to the table. You can literally put this in y1, the equation in y1, and then go to your table when h is 0 in or x is 0 and x is 2, your corresponding values will be that. But I want to show it to you how we substitute in. So it's going to be negative 16, 2. Basically, wherever you see t, you're going to substitute 2, right? You can do that math in your head if you want, or you can put it in the calculator, right? So this would be what? 2 squared is 4. 16 times 4 is negative 64. Negative 64 plus 100 is positive 36 plus 3 is 39, right? H of 0, if I substitute in 0 here, all my t terms, what happens? They become 0, right? So what am I only left with? Just my constant, which is 3. right? I'm not done with the question. I just got, so if you had checked it on the calculator, you should have gotten, I'm going to do a different color. You should have gotten 0 is 3 and 2 is 39. Okay, so that's how you should have gotten it. So now you're going to find your average rate of change, which is y2 minus y1. It does not matter. So I can do 39 minus 3 over, since I did 39 minus 3, I'm going to do 2 minus 0. Okay, so 39 minus 3 is 36 divided by 2, which is 18. And what was our units? Feet per second, right? So let's try the last example, example 4. It says when driving a car and an unsuspected hazard appears in the roadway. The table at the right shows the total stopping distance, which is the sum of the thinking distance and the actual braking distance. So what is the average rate of change in the total stopping distance in feet per mph between one car traveling 40 mph, which is miles per hour, and one traveling 60 mph, right? So what are we going to do? We're finding the average rate of change between 60 and 40. Those are our two x values. So corresponding, we're already given the table, and I'm going to do this in blue. So this is what, 40 and 119. So you're finding your average rate of change. So it would be what? 239 y2 minus y1 over x2 minus x1, which is what? 239 minus 119 is 120 over 60 minus 40 is 20, which is 6 feet per mph, right? So now there's part B to it too. It says explain what this rate or what is the slope meaning. What does the 6 means as it relates to braking distance? So this means I want you to actually pause the video and then check out my answer and see if you understand this. So this means the car slows, because we are braking, right? Slows at a rate of 6 feet. So every time you're braking per 1 mile per hour. Right, so that's basically about the lesson. Finish the closure and finish the remaining of the homework.